Hi everyone. This is lecture number 11. This is the lecture on primate taxa. You will remember that a taxon is a category of organisms, and that taxa is the plural of that word. So today's lecture is, the goal of it is to give you an idea of where you and other human beings sit in relation to other primates, evolutionarily speaking. So we'll go over the major primate groups today and try to give you an idea of your situation in that family tree. This chart that you're looking at now is a phylogeny of primate taxonomy. It's a phylogeny for the order primates. It shows roughly the times of divergence for different distinct groups of primates, culminating in us over here on the right. We're a pretty recent group. You see that some of these groups broke off rather early. For instance, there are the lemurs, the lorises, and the podos. The tarsiers broke off 50 million years ago. New World monkeys broke off maybe 35 million years ago. And you just see those straight lines extending straight up to the present where it says 0 million years ago. This is not to say that these groups have not been diversifying and changing and giving rise to new groups as time has gone on. It's just that this class is anthropocentric. This class is here to help you understand your position in the world, and so we'll focus on the taxonomical categories, the taxa, that are most relevant to your situation as a human being. So let's get on with that. So to recall, we are members of the order primates, and primates are distinguished by having hands, sometimes 4 of them, and by having nails instead of claws. There is an exception to that nails rule. We'll talk about that shortly. Primates have stereoscopic vision, and in relation to other mammals, they offer even more intense examples of sociality, even more intense parental investment, and even more extended development. That is, they take even longer to grow up. Now, the taxonomy is actually more complicated than the simple Linnaean categories of kingdom, phylum, class, order, family, genus, and species. And in fact, in order to make the Linnaean classification system fit to current understandings of evolution, there have been a number of categories inserted in between the classic KPCOFGS, King Philip cried out for good soup. So right here where you see this big arrow in between the levels of the order and the family, there are a number of subcategories, and these are what we'll be focusing on today. So we'll mostly be focusing on groups that fall between the level of the order and the rank of the family. So we have primates at the order level, but then there are 2 suborders in the order primates. They are Strepsirrhini and Haplorini. And then within Haplorini, which is our group, there are 2 infraorders, Platyrrhini and Catarrhini. Catarrhini is our group, and within that there are 2 superfamilies, Cercopithecoidea and Hominoidea. And after that we can go to the family level, talk about Hominidae, and go to the genus level and talk about Homo and also Australopithecus. But those are future lectures. We'll see how far we get. So, again, a little bit of review. There were early primates, and early primates were like the creatures that we called Plesiadaptus and Notharctus, even though they may or may not have been primates themselves. They were at least somewhere very close to the ancestral primates. And from their lineages, 2 distinct primate groups emerged. Now, notice here, these are color-coded for you. So if it's red letters, that matches the red box. So the first distinct group, we can call them Strepsirrhini. That's a suborder. Strepsirrhini includes the strepsirrhine primates, and the strepsirrhine primates include lemurs, lorises, and podos. The other big group was Haplorrhini, which is another suborder, of course, and that includes all other primates, including tarsiers, all the monkeys, and all the apes. So let's start with Strepsirrhini. The best known strepsirrhines probably are ring-tailed lemurs, very popular on the internet. They even had a television show on Animal Planet for a while. Um, you can note that they are members of the suborder Strepsirini because, unlike other primates, they still have a rhinarium. And a rhinarium is just the moist, mucus-secreting skin at the end of the nose. Most mammals have a rhinarium. Uh, there's always the reference to how do you know if your dog is healthy? He has a wet nose, right? So this is just the wet nose that dogs and cats and horses and other creatures have. Strepsirrhine primates retain this characteristic from earlier mammals. Also, something that distinguishes strepsirrhines is that they have a relatively large nasal cavity. You can see that he still has a muzzle here. Most primates do not have a notable muzzle. And what this means is that they have a pretty good sense of smell, which again is a trait that they retain from their mammalian heritage. Other primates have reduced muzzles and don't rely on smell quite as much as strepsirrhines do. So strepsirrhines also are distinguished from all other primates by the fact that they retain one claw. It's a toilet claw. So on every strepsirrhine's foot, there will be one claw. The rest of the digits will be covered in nails. And the toilet claw is used for grooming and for picking out bits of dirt and filth from those kind of hard to clean places. You can imagine. Strepsirrhines also have adapted their incisors and canines on their lower jaws into a comb, a tooth comb, which is also used for grooming. And here's just some pictures of some strepsirrhines for you. Let's see, can we see his claw? Right there, there's his little grooming claw. This is a loris, and this is a bush baby. You can see that they are primates. They have stereoscopic vision, but they have a enlarged muzzle versus other primates. But definitely, look, he has a hand for sure. That's got to be a hand. It's a funny looking hand. It's a different kind of hand. It does different things than our hands, but it still is a hand. All right, so we have these two suborders, Strepsirini, which we've just covered, and Haplorini, which covers all the other primates. So Haplorini has two flavors as well. Has two infraorders. The first one is Catarrhini, and then there's Platyrrhini. This other group here, Tarsiers, I don't know why I don't have a yellow box around them. Maybe because it was too hard to see. This is certainly hard to read. It's Tarsiers. Tarsiers. They're difficult to classify. They're sort of weird. They have a lot of traits in common with the strepsirrhines, but they seem to have more traits in common with the haplorhines, even though they look very much like a strepsirrhine and unlike most haplorhines. I'll show you. I'll show you on the next slide, I guess. The current consensus about tarsiers is that they should be counted as haplorhines, that they are just a very early offshoot from the haplorhine lineage. And the DNA analysis using the molecular clock technique indicates that that split is perhaps 50 million years old. So now let's see some tarsiers. So most living primates are vegetarian, or at least vegetable focused, and diurnal. But tarsiers are weird like that because they only come out at night and they only prey on other animals, that is insects usually, but they also eat lizards and things like rodents sometimes as well. They have these really huge eyes, which are the same size as their brain. Of course, you can't see the whole eye, but it extends all through this orbit here. This is an adaptation to hunting at night. So just check this out. Here's the tarsier's eye. Here's his brain. Here's your eye and your brain. I think this is a picture of the guy who did this research that revealed that tarsier's eyes and brains, well, they're not just adapted for processing complicated visual stimuli in the dark, but the really striking thing is that the tarsier's eyes actually do a lot of that neural processing of the sight data, of the data that they get from the light bouncing off of objects. Whereas in humans, the eyes are more focused as receptors, and all the processing goes on in the brain, in the back part here. But tarsiers, some of the work that the human brain does for seeing, tarsiers do that work in their eyeballs. And this is actually a convergent adaptation with something that jumping spiders have going on. And that's not too surprising. Jumping spiders actually, even though they are insects and only distantly related to primates, right? They actually have a lot in common, ecologically speaking, with tarsiers. They're both hunters who hunt by sight and who prey upon their prey items by leaping on them. And I'll put this video up on the internet, but if you want to watch it yourself, it's a tarsier hunting. It's a lot of jumping on insects and then munching their heads off. So let's get back to the rest of Haplorini. There's two infraorders there, remember, Platyrrhini and Catarrhini. The characteristics that identify all haplorhines, including tarsiers, is they have a relatively reduced nasal cavity with shortened muzzles, and because of these factors, they have a relatively weak olfactory sense. So they tend to be much more sight-based. So the platyrrhines is the next group that we'll go over. They are also called New World monkeys, and that's for a good reason. Platyrrhines are only found in the Americas, that is Central America and South America. There are no native monkeys in North America. They may have been outcompeted by rodents like squirrels in North America, but in South America and Central America, there may have been the possibility that there was just more niches, more professions available in the climates and biomes available in those places. The platyrrhines, they are separated from other kinds of primate by about 40 million years. The divergence between the catarrhines and the platyrrhines is about 40 million years old. And the idea when this happened, how they got to South America is actually pretty interesting. The consensus now, although it's still a highly questionable theory, is that New World monkeys got to South America from Africa by basically getting stranded on vegetation rafts. You know, maybe a storm blew over a clump of trees, and there were a few African monkeys stuck there, and they floated across the Atlantic Ocean, ended up in South America, and from this group or several groups like that would have given rise to all the diversity of New World monkeys nowadays. It's an unlikely tale, but it's also, well, what it has going for it is that weirder things have happened and that there have been documented incidents of vegetation rafts crossing oceans. So it's the best idea out there. So platyrrhines, like I said, they only live in the Americas. What distinguishes them from other kinds of haplorhine are their nasal structures. So check out this guy. He's a capuchin monkey. You see his nostrils are aimed to the sides. That's the platyrrhine nose there. You can see that also on this Wakari monkey. You can't see his nostrils so much, but that's only because they're so far apart on the sides of his nose here. And all this part here is flat or smooth, no holes. Another trait that you find only among platyrrhines and not among catarrhines is prehensile tails. Not all platyrrhines have prehensile tails that act as a fifth limb, but you do find several species of platyrrhine monkey that do have prehensile tails, and which have actually used them as another limb for their arboreal lifestyle. New World monkeys tend to be very arboreal. They tend to live in trees, whereas Old World monkeys sort of are all-terrain monkeys. So here, let's see if we can tell the platyrrhines from the catarrhines based on their noses. Remember, platyrrhine nostrils go out to the sides, and catarrhine nostrils go down. So we'll start with an easy one, a chimpanzee. You know that's a close relative of us, and you should know what group he's in already. And you should be able to note right away his nostrils are pointing down. They seem to flare up at the sides, don't they? Just like ours a little bit sometimes, but mostly they're oriented down. So he's a catarrhine. This guy, what is he? Well, yes, it's a little difficult. He's a langur, which is a kind of catarrhine. He lives in India, probably. And though his nostrils also flare up on the sides, they are more or less pointed downward, right? The way into his nose is that way. How about this one? Okay, that's a night monkey, also known as an owl monkey. It's another weird nocturnal primate. It is a platyrrhine. You can see these eyes are nocturnal adaptations. Look at those big staring eyes. But he's a platyrrhine, and you can tell, first of all, he's got this broad septum here. And his nostrils, though they are sort of oriented on the bottom, they are aimed out at the sides. The way up his nose is from this way. Okay. This one? Well, you've already seen a capuchin. You know he's a platyrrhine. He's got a broad septum here, nostrils out to the sides. The Wakari, also very easy, broad septum, nostrils, definitely on the sides. This video will be up, you'll see it. That video is capuchin monkeys using tools, you'll see. It's actually, we'll just go back a little bit here. These guys using tools. We're a relative of these guys. These are black and white capuchins. The ones in the video will be brown capuchins. I give you that video because there's this sort of persistent notion that New World monkeys are somehow less cognitively adept, less smart, or less clever than Old World monkeys. And the video showing the capuchins using tools sort of militates against that idea, that these platyrrhine primates are also clever thinking characters who manipulate the world around them. Okay, so to the catarrhines now. So the catarrhines include all the other primates. That includes the Old World monkeys, it includes all the apes, and it includes humans and their relatives. So we can break Catarrhini into two superfamilies. The purple superfamily is the Old World monkeys, known as Cercopithecoidea, and then the sort of mauve or lavender or purple red, deep purple, maybe deep red, I don't know, blood red boxes, Hominoidea, which is the apes. So Cercopithecoidea, that's all the Old World monkeys. That means any monkey that you find naturally occurring in Africa or Asia or in Europe, there's one species in Europe, is a Cercopithecoid. Cercopithecoids are extremely social, and I'm not saying the platyrrhines are not, but the Old World monkeys are sort of social specialists. They can live in very large groups. There's a lot of diversity among them. These are snub-nosed monkeys here from East Asia or Southeast Asia. This is a Hamadryas baboon from, I believe, Southeast Africa. This is a Francoise langur, also from Southeast Asia. A lot of diversity, and they're large group specialists. We've talked about some catarrhines already. My favorite catarrhines are rhesus macaques, who live in South Asia, mostly in India. About half of them live in India. And these guys are a great example of the sorts of adaptations that are typical of catarrhines or cercopithecoids, what really catarrhines as a whole, for maintaining social cohesiveness. You remember all the stuff I told you about communication in the last lecture. Well, let's look at this guy's face. This was a monkey I knew. I believe this was Sundarlu, pretty guy, who lived at Jaku Mandir in Shimla in India. And I tried to show you a picture of another male macaque, Babu, and I tried to show you his quote-unquote makeup. Sundarlu has a much better array going on here. You can see he's got these red streaks at the corners of his eyes that bring attention here, and he's got a little bit of red around his eyes that bring attention to them as well. And then he's got this hairy mouth here, helps him cover up the fangs he's hiding in there. Here he's chewing, and he just looks kind of docile. His friend behind him in this other picture is actually working a water faucet. Anyway, so these facial adaptations, we could say that the catarrhine primates as a whole, that's including the cercopithecoids and the hominoids as well, all the old world monkeys and the apes, we could say that the catarrhines as a whole are very facial. They're sort of facial specialists. The New World primates, they have their own facial expressions and their own ways of communicating, but it's just their facial mode of communication doesn't seem to me to be quite as rich, which is not to say that they're lacking anything in particular, but rather that they have other ways of communicating, and that faciality is characteristic of catarrhines. Here's a picture of some catarrhines. Okay, the cow's not a catarrhine. It is a mammal. It's not a primate at all. Here's a catarrhine, a langur, and here's a catarrhine, a human. Like I said, catarrhines are really social, and they really don't mind hanging out across species, but I guess you could say the same thing about this cow here. So that last guy, this guy right here, he's a catarrhine. His superfamily is Hominoidea. And Hominoidea includes all the apes. So this is a siamang. This is a kind of ape. It's a relative of gibbons. This is Lucy, an Australopithecus afarensis. She's a kind of ape, a relative of us. The hominoids include two families. The first family is Hylobatidae, or Hylobatidae, which includes all the gibbons and the siamangs. This is actually a siamang. That last guy was a gibbon of some kind. And then the other hominoid family is Hominidae, which is, you can see this is the backside of a gorilla. So you know an ape, you know it's a member of the family of the superfamily Hominoidea. You know it's an ape of some kind, a creature that lives in one of these two families, because it doesn't have a tail. Hominoids do not have tails. Now, there are a few monkeys who don't have tails, but luckily there are a number of ways you can identify a member of superfamily Hominoidea. But the number one thing is it doesn't have a tail. If you're at the zoo and you're watching a group of primates sit around and chew on some vegetables, and you tell somebody, hey, look at the monkeys, you're wrong. They're not monkeys, they're apes. It's a different thing. And I guess the last thing to add is that most species in the superfamily Hominoidea live in Africa and Asia. In fact, the only species of hominoids that are not confined to Africa and Asia is humans. So in the superfamily Hominoidea, we're still talking about the superfamily. There are some other traits in addition to that taillessness that you can use to identify them. So one thing, they have lengthened arms. Versus monkeys, their arms are quite lengthened, and in most apes, the arms are actually longer than the legs. Also, let's go down here. The lengthened arms actually, it's an adaptation to a certain mode of locomotion, a certain way of moving around the environment called brachiation. Brachiation defined as hanging locomotion with the arms. In addition to the lengthened arms, some other traits that are adaptations to that mode of locomotion include shortened lumbar vertebrae. So these are all apes here. A chimpanzee, genus Pan, a human, genus Homo, and a gibbon, genus Hylobates. And versus a monkey, their lumbar section of the spinal column here is reduced, and the vertebrae in it are shortened, widened, and made thicker. This is in order to support the torso while they're hanging. They also have a widened collarbone versus monkeys. You can see this especially on humans. This is again a muscular adaptation to supporting body weight with the arms. And finally, their scapulae, not really easy to see here, Their shoulder blades are rotated to the back side of the rib cage rather than on the side. The monkeys would have them on the sides here because monkeys are still basically quadrupedal, four-limbed movers. But in order for brachiation to work, you need to be able to rotate your arm all the way around. And so the shoulder blade must then be on the back if you are an ape and you want to rotate your arm around. This is explained in more detail in the bone demo, which is included with the lectures. It's a separate video. Just to review and to show you where these things are on a quadrupedal mammal, check out this horse who has very kindly allowed some veterinarians to paint him or her. This is the shoulder blade. It's on the side of the rib cage. If this were an ape, it would be on the back. The lumbar vertebrae of the horse are actually pretty short and thick. In other animals, like a monkey or a cat, you'll see a lengthened section here that will allow a curvature. The horse doesn't need to be able to curve its back as it runs. It doesn't take its torso and bend it as it strides because it has very long legs. But many other mammals, including monkeys, will have a lengthened lumbar section here so they can bend their backs as they're covering ground. Here's the monkey. So versus the human, right? This is a very long section of lumbar vertebrae. And for the monkey, his shoulder blade isn't quite on his back. It's sort of almost there, but it's on the sides. And that's because, like most mammals, the monkeys, this monkey is a rhesus macaque. This macaque would be traveling usually most of the time with his limbs underneath his body. Again here, check it out. Here's the gibbon brachiating, shortened lumbar, shortened lumbar. Here's our shoulder blades on the back. The gibbons are in the same place. So why would you want to brachiate in the first place? Why is that a good idea? Why go to all this anatomical trouble so you can hang upside, well, not upside down, but so you can hang with your arms from branches? Well, the answer to that, or the best guess, is that it's a feeding adaptation. So say you're a quadrupedal monkey, that is, you don't have the adaptation to hang, right? A monkey is like a dog. You'll see this in the bone demo. But a monkey is like a dog. That is, its limbs have to go out in front of its body and can have to stay there within a certain range. You can't pull the monkey's limbs all the way to the sides like you can with a human dance partner. Remember, what is it like to dance with your dog? Well, you can't spread their arms too much. You just have to take their little paws and move them up and down. You can't open up their arms because their shoulder blades don't go that way. So if you're that sort of quadrupedal creature that does not have the adaptation for hanging, and you go out to the end of a very long branch, you're going to have a certain range from which you can pull the berries, the flowers, the leaves, whatever it is that you're eating. If you can hang from that branch, you can get everything in this range, plus you can pull down things hanging above you, and then finally you can hang off of a branch and get the things underneath it too. Right? Fruit is heavy, it tends to hang. And so this is just a way of sort of beating the tree's own adaptations to keep things away from you. Although trees want you to eat that so that you can spread their seeds around. So that first family of hominoids I mentioned, the Hylobatidae, you can call the members of this group Hylobatids, or you can call them gibbons and siamings. And they are the only quote-unquote true brachiators. That is to say that they're the only ones who really specialize for brachiation all the time. For the other apes, these adaptations for brachiation are still useful as a feeding adaptation, but it's not really their sole mode of locomotion. Gibbons, however, are super good at it. These two videos, which will be posted, show gibbons brachiating, and they're very fast. They're very good at it. It's really fun to watch, actually. So into this family Hominidae. So this is not just apes. We could call this the great apes. That is all the ones all the other apes. They used to get called the great apes because they're generally quite a bit bigger than gibbons and siamings. And there's also a notion that they're smarter or they have greater cognitive capacities. Well, they do different things with their brains than gibbons and siamings do with theirs. Gibbons and siamings really good at swinging through the trees with brachiation, um, doing duets as they sing to one another, stuff like that. But hominids, with their larger cortexes and their more intense sociality, more intense parental investment, and their longer development as children, they are specialized to use tools and to pass on traditions. Here's a picture of a couple hominids here, right? You really can't tell the difference, can you? Okay, I know it's rather easy, but there are a lot of similarities here. I mean, the same position here as it's just so striking. These are similar, very similar creatures I'm showing you. So family Hominidae also comes in two flavors. It has two subfamilies. The first subfamily is Ponginae, and that includes the orangutans. And then the second subfamily is Homininae, which includes humans and the other apes. Homininae has two tribes in it. They're not marked up here because it's easy. The tribes are Gorillini and Hominini. Gorillini contains the gorillas, and Hominini contains the humans and the chimps. So we'll talk about the Pongonins, members of the subfamily Ponginae. They are the orangutans. There's just one genus of orangutans, genus Pongo, but there are two species. There's Pongo pygmaeus, which is the Bornean orangutan that lives in Borneo, and there's Pongo abilii, which is the Sumatran orangutan, lives in Java. They're found in Southeast Asia and in Oceania a little bit. I guess if you call Sumatra and Borneo Oceania. And they generally live solitary lives or lives in small groups, which may be an adaptation to their fruit-eating lifestyle. That is, fruit in their habitat can be difficult to find, so it might not be the best idea to share it when you find it. So small groups might be a good idea. They use simple tools. You can see the female orangutan here with her child. She's using a bough of leaves as an umbrella in a storm. She's keeping the water off her head. And they're really capable as mimics. So they can learn to go through physical maneuvers by watching. They don't always seem to know what they're doing if they say they're mimicking a human behavior, but they can definitely mimic. Orangutans are also sexually dimorphic, and what that means is it's pretty easy to tell the difference between males and females. Well, often. The story is actually more complicated here. But when we say they're dimorphic, we say that there are at least two distinct phenotypes that generally map onto male and female, but it's more complicated than that with orangutans. But the male phenotype can be marked by having phalanges, these big flaps on the sides of their faces. Or here's a flange, a big flap that's hanging down over this guy's chest. And that's a mark of a mature male. So this video, which will be put up on the website, is of an orangutan named Supina, and she's doing the laundry. It's an example of the mimicking. She doesn't really seem to get the idea of what to do with the laundry. For instance, she eats the soap, but she's mimicking what she's seen people around her do. So let's talk about orangutan reproduction for a minute here. This is interesting, and I have a point to make with it. So generally, let's not even say generally, but let's just start off with this, that the male orangutans, dominant male orangutans, will tend to keep large ranges, okay? And their ranges will generally overlap with the ranges of females, but not with the ranges of other males, or at least not other males who keep territories. If you are the sort of guy who has developed flanges, the flap for the chest and the flap off to the side of your cheeks, then you probably defend a territory like this. You probably maintain a territory. That sort of behavior is typical of flanged males. And how do you maintain your territory? Well, you act aggressively towards anybody else with flanges. You tolerate the presence of females, anybody without flanges, but you act aggressively once you see those flanges and hear the calls. These flanges actually are a hormonal response to social interactions. So if a male orangutan, a sexually mature male orangutan, manages to maintain social dominance over a territory, his body will respond to that success at maintaining a territory by releasing hormones that stimulate the emergence of these flanges. So, generally speaking, younger non-dominant males don't hold down their own territory and they don't grow flanges. Um, so the complicated part of this story is that orangutan males actually exhibit something called bimaturism. That is, they have two different forms of sexual maturity. There is a flanged form, and I've already discussed them, told you that they guard a territory, and how these guys try to attract females, how they try to accomplish reproduction, is by hanging out in an obvious place in their territory that they maintain, and calling out loudly, making a lot of noise, sort of, making a big hoopla, alpha male sort of behavior, if you like. But there is also a non-flanged form of male. See, if you're a male orangutan and you can't quite manage to guard a territory and you can't quite manage to get into that situation where your flanges are all over the place, you're not, you're not fighting off other males necessarily. Well, there's another way to go about reproduction. Basically, what you do is you don't bother with spending all the energy hooting and fighting off other males, but rather you just sneak into their territory disguised as a juvenile. No flanges, no problem. This guy won't fight you if you don't have your flanges and you don't make a big fuss. So that means then you can just go to the female's territories without worrying about guys like this, and you can mate with them that way. Empedocles, love strife. So, into the subfamily Homininae, we can talk about gorillas. Gorillas are in their tribe Gorillinae. Right, Gorillinae. Yep, had to think about how to say that. And there's only one genus of gorillas, and it is gorilla. Easy enough. Two species with maybe two species with maybe 4 to 5 subspecies. The first species of gorilla you should know is gorilla, which are the lowland gorillas. The most common gorillas are western lowland gorillas, scientific name gorilla. You see these guys at the San Francisco Zoo if you get a chance. The other species of gorilla is gorilla beringii, which is the mountain gorilla, and they're pretty easy to tell apart, the lowland gorillas versus the mountain gorillas. The mountain gorillas are a little bit more robust, and they are fuzzy. They have lots of long hair. It gets cold in the mountains. Lowland gorillas don't need it quite as much. Gorillas generally live in single male, multi-female groups, but either sex might leave the group when they reach sexual maturity. It depends on the social dynamics in the group. In a multi-sex group, there's usually an alpha male, a single male who's sort of in charge. He's a silverback, and we call them silverbacks because they have these graying patches on their backs that mark them as not just sexually mature, but as sort of senior dominant males. It's sort of analogous to going gray in humans. So gorillas have low metabolisms and they keep pretty small ranges. They don't really maintain territories, but they range around areas that are smaller than many other apes. And this is because their food is very easy to find. They're complete vegetarians. They don't eat any meat. And so if you live in the forest and you eat all sorts of tough foods, and they really do. Look at this female here. She's eating nettles. She's actually scraping the thorns off of the nettles before she eats them, although I don't know how good of a job she's doing from the expression on her face. But if you've got the ability to eat bark, eat tough plants, even things with thorns, then you don't really need to look very far for your food if you live in a forest. So you don't need a high metabolism. You can kind of just sit around all day and eat your plants. There actually was a study that found some animal DNA in the feces of gorillas, suggesting that maybe they actually did eat animals once in a while, but it turned out that these were insects that were probably accidentally ingested as the gorillas were eating plants. I mean, you'll find a little bit of insect DNA in the feces of cows, for instance, as cows certainly accidentally eat insects. Although it's interesting, many insects have actually developed responses to the chemicals, the sort of the scent of mammal breath, and so when they smell a cow's mouth coming close, they'll jump off. Hey, there's a famous gorilla I want to tell you about, Coco. This is our first non-human totem figure. And Coco's teacher, Francine Patterson Penny, they live right around here. Coco was born in San Francisco Zoo, and she was sort of a staff member in a way, not really, at Stanford University for a while. But now she lives in Woodside, which is where I live too. There's a lot of big houses and big properties around here, and so it seems like a natural place to put a gorilla if you're trying to live with a gorilla. Um, Penny Patterson uh, is sort of this eccentric character in the world of primate research. Uh, People at Stanford will claim that she more or less stole Coco from them. Uh, she maintains that she's just undertaking the same research that she's been taking on for years. Well, let's see here. Here's the story with these guys. Penny has taught Coco to use sign language, an adapted version of American Sign Language that we could call Gorilla Sign Language, GSL. And Coco uses the letters that she's learned, the words that she's learned, to express herself. And she sometimes comes up with novel combinations of signs in order to express ideas that nobody has taught her a word for. And so in this way, she talks. Now, does she have language? That's very debatable. Uh, there's certainly a lot of people out there who have a lot of different ways of explaining that she doesn't have language, but that's really beside the point. She does understand some English. She empathizes with humans. That is to say that she has an ability to communicate with people on a level that, or in a way rather, that most apes don't have. And we really could say that this is a result not because of her particular cognitive capacities. Some people call her a genius ape, but I think of genius apes the same way I think of genius humans. It's not really about that individual, but rather it's about the network that that individual is in. And whether or not Coco has language per se, as it is defined by any scientist or scholar, she certainly has a complex means of communication that is a hybrid of human means and gorilla means, and it emerges from a particular social community that she finds herself in. Uh, Coco is very famous for keeping pets and giving them names. Many people have heard about her relationship with her first kitten, whose name was Albal. And many people have heard of the story of how Albal was killed and hit by a car, and it made Coco very sad. And she was in mourning for the loss of her kitten for a long time. Uh, this story is, of course, popular because it's very dear, but it's also popular because it demonstrates that Coco, as a gorilla, has some of the same emotional traits that we humans value. That is, she's capable of forming friendships, she's capable of caring for other kinds of living things. She's gotten more kittens since then. She has a couple of kittens now that visit her from time to time, I understand, although she might have a full-time kitty now. And uh, if you go to the Gorilla Foundation website, you'll see that uh, Penny Patterson has reported that Coco wants to have a baby. So actually, by now she may no longer live in Woodside, although I think I figured out where she lives. They don't advertise their address, but there's a place in Woodside I've passed many times on the road that has a very large cage that's slightly visible from the road. And it's just such a large enclosure that it's got to be an outdoor enclosure for a large animal, perhaps something like Coco. But anyway, she may not actually live in Woodside by now. They've been talking about moving her to a um, a rescue center in Hawaii. No, she wouldn't be undergoing a rescue herself, but she would be collaborating with humans in rescuing baby gorillas. Coco's actually quite old now, so she was born in 71. That's 81, 91, 2001, 2011. So she's like 43. She's a senior citizen for gorillas. So she may or may not still be able to have a child, and they've tried to hook her up with males several times, but she doesn't really want to socialize with male gorillas. So their plan now is that they're going to put her in the care or partial care of a series of orphan gorillas rescued from poachers and from the black market in Africa. And so she's going to live in Hawaii and be a foster mother for these orphan gorillas. It's actually a really great idea, isn't it? Here's an interesting story. This is a great example of genetic drift. This would be a great example of evolution that you could narrate for the final exam. And it also demonstrates an evolutionary connection between humans and gorillas, as well as a social connection in a way between humans and gorillas. So anyway, okay, so I don't want to get ahead of myself. So check this out. These things, well, you know what these things are. These are mammals. Rodents, they're mammals. Old world monkeys, gorillas, humans, and chimps. These things are lice. Look at this. So we have on this chart here, we have the divergence times, the estimated divergence times between species. So chimps and humans diverged about 6.1 million years ago, according to this chart, which is pretty close to the 5 million year number that always gets thrown around. This doesn't mean that humans evolved from chimpanzees 6 million years ago. Rather, it means the last common ancestor of humans and chimps lived about 6 million years ago. That last common ancestor was neither human nor chimp, but something that came before both of them. And here, the last common ancestor of chimps, humans, and gorillas would have lived 11.8 million years ago. The last common ancestor of apes and the old world monkeys, including my favorite monkeys, the rhesus macaques, would have been around 24 million years ago. Okay? So, scientists have long been able to distinguish between different kinds of louse based on, uh, well, anatomy, right? So the rodent lice, they have distinct anatomy. This is a louse that's specialized for living on mice, rats, squirrels, etc. This louse is specialized for living on monkeys. This louse is specialized for living on gorillas. This is a human hair louse, and this is a chimpanzee louse. The chimp louse is very similar to the human louse. They're both pretty similar to the gorilla louse, but not very. You can see that the gorilla louse is broader. All these are somewhat similar to the monkey louse, but you can see there are some definite changes there. The monkey louse has a longer head, has a somewhat broad body. Its limbs are a little bit shorter and more robust than these guys. And they all share some similarities to the rodent louse, but the rodent louse is quite distinct. So, there's a problem here, though. It's not an easy story. Humans actually have two kinds of lice. We have head lice and we have pubic lice. Now you can right away, by looking at the anatomy here, see the problem. Human pubic lice do not seem to be that close to human head lice. In fact, human pubic lice seem to be much closer to gorilla lice. Now, one now discarded idea of how pubic lice and head lice evolved into these two separate forms is basically genetic drift. So you will imagine the ancestor of humans would have been like a chimpanzee in that it had hair all over its body. But as humans evolved and adapted for life on the savanna in Africa, we lost a lot of our body hair. And now the two thickest regions of our body hair are our pubic area and on top of our head. It's genetic drift. The idea would have been that these two kinds of lice would have been one kind of louse back in the day when humans had one big sea of hair covering their entire body. But as the pubic hair was separated from the head hair, these two kinds of louse would have genetically drifted apart and then turned into two separate species. It's just like the snub-nosed monkeys I talked about, but instead of rivers and mountain ranges separating the two populations, in this case it would have been a vast expanse of hairless body separating the two places where these kinds of lice live. But then there's always been that anatomical problem, that human pubic lice look much more like gorilla lice than they do head lice. Well, some smart folks went and they sequenced the DNA of lice. And using a molecular clock, they established that chimpanzee lice and human lice separated about 5.6 million years ago. Okay, that makes sense. That's pretty close to the time when chimps and humans would have separated, right? And so as these lice got carried away on chimpanzees, and these lice got carried away on human ancestors, these two populations would have genetically drifted apart, right? Because these guys live on these continents called chimpanzees, and these guys live on these totally separate continents called humans, right? The DNA sequencing and the molecular clock revealed that the last common ancestor between these lice and the gorilla louse was about 13 million years ago. Which, okay, that's not too bad because these are, broad numbers. They're bound to be a little wrong. That seems to fit quite well with the divergence time of gorillas from other apes. And they gave a date of 23 million years to the divergence of monkey lice from ape lice, which makes great sense considering that apes and monkeys diverged about 24 million years ago. But then what did they find when they sequenced the DNA of pubic lice? They found that human pubic lice separated from gorilla lice only 3.3 million years ago. That means human ancestors, long after they had separated from chimpanzees, somehow got pubic lice or crabs from gorillas. How did that happen? Okay, I know what you're thinking, and it's not that likely. What you're thinking is, right, they must have been sleeping with the gorillas. Nah. The idea is, okay, right? A human ancestor, even an Australopithecine, we'll learn about the Australopithecines later, but it's quite a different creature from a gorilla. There's probably no way that these guys were getting together and then deciding they were similar enough to have sex. Not happening. The idea is that maybe the humans or the human ancestors 3.3 million years ago, these would have been Australopithecines, we're coming upon gorillas' nests. And we're sleeping on a regular basis in nests that had been constructed and then abandoned by gorillas. And so gorilla lice would have been in those nests. And so 3.3 million years ago, the ancestors of us, our ancestors, were pirating gorilla nests, and that's how we got crabs. And over time, pubic lice specialized for the patches of hair that appeared on our lower abdomens. And these lice, which had previously had the benefit of our entire bodies, ended up specializing for the hair on our heads. They were probably outcompeted by the gorilla lice for our pubic areas. And here are the scientific names of all the lice: Pediculus schaffi, Pediculus humanus, Thyrus pubis, Thyrus gorillae, and Pedicinus and Fahrenholtzia. So the taxonomy reveals also, right, that they are related in troubling ways. And here they are up close, just in case you want to see. This is a pubic lice, pubic louse. This is a head louse. This is a gorilla louse. On to chimpanzees. Chimpanzees, they're in the genus Pan, named after the Roman god Pan, who was Dionysus. He was the god of debauchery and parties and also the wilderness. There are two species of Pan. The first species, the most common one, is Pan troglodytes. This is your common chimpanzee, also known as a robust chimp. The other species is Pan paniscus, sometimes called a pygmy chimp or a gracile chimp, but preferably referred to as a bonobo. Anatomically speaking, bonobos tend to be smaller than chimpanzees, but the major differences between these two species are social and genetic. So we'll talk about these social differences first. So, well, rather the social commonalities. Oh, hold on, differences. These are Pan troglodytes. Okay, Pan troglodytes live in multi-male, multi-female groups. This is the common chimp again, the robust chimp. The females disperse from their natal groups when they reach sexual maturity. What that means is when they're sexually mature, they get kicked out of the group. Chimpanzees usually eat fruit, but they vary their diet. Both species of chimp are known to eat meat. Pan troglodytes perhaps eats more of it. They are known to go on hunting parties. They're even known to use small sticks, which they have sharpened with their teeth, as spears when they're trying to kill a monkey or a bush baby or something like that to eat it. Yeah, they hunt other primates. They also eat small antelopes and deer, like duikers. Common chimpanzees, robust chimpanzees, aka Pan troglodytes, this T should be lowercase, they live in patriarchal societies. That means they're male-dominated. All the power tends to be with an alpha male and a small coterie of his friends. The males form the backbone of the group. They don't leave the group when they reach sexual maturity. They are incorporated into the good old boys club. And Pan troglodytes tends to be more territorial. The males they actually form patrols and go on patrol in groups, seeking out intruders. It's an activity that's well, I guess we could call it militaristic. It's a disciplined activity that I've been told they take very seriously. One of my professors, Nate Dominy, who now teaches at Dartmouth, told class a story about one time when he was in Africa as a researcher studying chimps, and he was following a group of males on patrol around, and they were taking great pains to be quiet, taking great pains to be stealthy as they sought out intruders from other chimpanzee groups. And whenever he would Nate, whenever he would step on a stick or something and make a noise, they would all turn around and glare at him like, dude, you are messing this up. Adrian Zillman, who wrote your coloring book, has noted that the females who are entering another community or another community's territory are particularly at risk. And it does seem to be the case that these male patrol groups will attack females with greater ferocity um, and seek to kill them with greater frequency. Uh, who knows why this could be, but it could actually be a calculated tactic to affect the reproductive success of other groups. Or it could just be a sort of cultural behavior that is the result of a very strictly patriarchal society. At any rate, you don't want to get into a fight with chimps, as you probably have heard over the past few years on the news. Chimp attacks can be very bad. They tend to go for biting at the face and at the genitals. Um, they disfigure their opponents at their most sensitive places. You may know the story of a lady who was attacked by a domestic chimp and had her face completely removed. And then she underwent plastic surgery, wrote a book, made appearances on talk shows, uh, has been advocating for changes to be made in the regulation of the keeping of chimps in the United States where this attack happened. Pan-Paniscus, the bonobos, they're quite different from chimpanzees socially. Their troops are matriarchal. That means that power tends to be invested with the females. Uh, they're actually quite egalitarian, however, so while there will be a sort of matriarch or an alpha female, and while there are different ranks in the society, there isn't necessarily a single character who's in charge. Uh, Rather, decisions might be made as a group. Unlike chimpanzees, when they reach sexual maturity, their offspring may go, either sex of offspring may go or may stay. It depends on the particular social situation that the bonobos live in. Uh, this is supposed to say bonobos resolve conflict through less violent means, but I guess the word means has been deleted thanks to the slide. When I convert it to this new slide program, it changed some of my slides for me. But anyway, they're less violent than common chimps. And in fact, they're commonly known as the sexy apes. See what I'm talking about? They use nonviolent affiliative behaviors to avoid conflict. So they prefer to groom instead of to punch. And they use a lot of sex acts. They have a lot of sex to relieve tension and to resolve conflicts. Um, some authorities even note that they have different gestures for different sex acts. Uh, so you might, if you ever meet a bonobo, don't over gesticulate with your hands. You don't know what sort of mixed messages you might be giving them. In fact, actually, all chimpanzees use gestural communication. This guy and this guy, what do you think they're saying? They're saying, give me, give me. Uh, this is a sign that's common between humans and chimps. In fact, you can make this sign to chimps at the zoo, and they will take note, if not necessarily respond, because they will probably also take note of the fact that they are separated from you. And even if you are asking for them to give you something, A, they couldn't do it, and B, they don't want to. But it is something that chimps and humans can use to communicate with one another, extending the hand and sort of making a motion to move the palm up and down to gesture sort of towards oneself. It means give it to me. This guy's also using his hands to gesture. What is he communicating here? He's communicating, get out of there, back off. I've got a stick. I'm going to get you with this. Chimpanzees do use weapons. They don't carry around clubs or anything, but they know how to pick up a stick and fight with it. And they know, some of them know how to use spears to hunt smaller animals. So here's another non-human totem I want to introduce you to. This is Kanzi, another quote-unquote genius ape. He's a bonobo, and this is his teacher, Sue Savage Rumbaugh. Kanzi was born at Emory University. His birth mother was Laurel, but he was kidnapped by the sort of lead female in his troupe, Matata, who adopted him and raised him as her own child. So the interesting thing is that Matata, this is actually kanji, but Matata was being trained to understand lexigram symbols. So these are symbols, each one of them represents a word. And so what Sue Savage Rumbaugh, a younger version of her, was trying to do was trying to teach Matata to form sentences by touching the lexicograms that she wants to use. So by touching the lexicograms in order, she could create a sentence using multiple words. Well, the thing is that Matata never got to be very good at the lexicograms, but baby Kanzi was there with her the whole time. And even though Sue never taught Kanzi how to do it, not in the beginning at least, he learned. And one day he just started using the lexicograms spontaneously to communicate with his mother and with Sue. So now, as an elder chimp and as the dominant individual in his troop in Des Moines, yeah, he's in Des Moines. He's at the Great Ape Trust in Des Moines. He knows 200 syllables. He uses these to form sentences, and he can combine these symbols to express concepts that he hasn't been taught about. Kanzi is the best hope for, well, okay, that sounds wrong. If you are of a mind to be concerned about defining what language is and what language is not, then Kanzi is sort of the best candidate for an ape who can actually use human language. The defining character of language here would be a grammar. Coco doesn't seem to understand grammar, but there is an argument to be made that Kanzi understands something about word order and he understands something about the different meanings that emerge from the different orders that words can come in. So he might actually have a grasp of language, but again, I think that question is sort of beside the point. He's using a very language-like way of communication to engage in a social group with humans. So like I said, he's the ranking male in his troop at the Great Ape Trust in Des Moines. That's in Iowa. And some of the researchers at the Great Ape Trust, including Sue, claim that Kanzi also tries to speak, that he tries to make words come out of his mouth, like Sue. You can find videos of him talking on the internet. It's not entirely convincing, but then again, I mean, he's vocalizing, and he's vocalizing in a strange way, and it sort of could be that he's calling out, so I'm not ruling anything out. But he also understands spoken English pretty well. This video, which I will put up for you, depicts him responding to Sue. Sue is wearing a mask in the video so that she can rule out the possibility that he's actually responding to her eyes or to her gestures. Rather, he's hearing the words that she's saying and doing as he's asked based solely on the words. But there is a tricky point in the video where he seems to start to complete the task before Sue has finished asking him to do it. So there's some monkey business in this ape communication. Maybe a little bit, but regardless, Kanzi is obviously a very talented character. So still talking about chimpanzees, chimpanzees exhibit noticeable traditions, which is to say that chimpanzees in different communities, in different places, have different repertoires of technology. So, for instance, the chimpanzees in Boso have, they throw rocks. They are known to throw rocks. But the chimpanzees in Kibale only throw rocks, maybe sometimes, maybe individuals know how to do it, but it's not something that the whole group does regularly. This chart, I understand, is too small to see. I will include the article. It's a Jen Goodall article. I'll try to include that on the website. It's very short. There's not a lot of text, The chart itself is very interesting, something worth looking at. Chimpanzees in Kabali, for instance, here, this looks like they know how to get honey from bees. Chimps in Budongo don't have this tradition. They don't know about that. Mahali does it, Gombe chimps do it, chimps in Thai do it, but chimps in Bosu don't do it. It's a tradition that Bosu chimps don't have. And this could also, a tradition of using tools can manifest in lots of different ways. Could be, for instance, whether chimps use a spear to hunt. This guy has a spear. Look at him crouching over, sneaking around. He's got a spear. He's going to get himself a bush baby. And here, look, these spears are actually sharpened. This is not a technique that all chimp communities know how to do. So what we're looking at is we're looking at different tool use traditions in these communities. And if they've got traditions, then they have what we call culture. They have what we think of as culture. What is culture except differential ways of behavior native to distinct communities? So here's a definition of tradition for you. It's knowledge passed on through learning, not genetic inheritance. Uh, so at some sites, chimps have a tradition of using stones to break open nuts. And this guy, Julio Mercader, in 2008, uncovered a stone tool site that was 4,300 years old. And it had a tool used for cracking nuts and a rock with an impression upon it, a depression in it that had apparently been made uh, by the repeated banging of a stone down on a nut, or on a long series of nuts over time. He analyzed the pollen grains that were found in cracks in the tools, and he identified the pollen grains as belonging to species of nuts that humans uh, do not eat. But you know who does eat these nuts? Chimpanzees. And so that's evidence that these chimps, whichever chimps, I forget the site at which, the name of the site. I can find it for you, of course, if anybody's interested or wants to even write a paper on this. Uh, so these chimps had been using this site for over 4,000 years. That's evidence of a long, ongoing tradition. It's not leaps and bounds of technological advancement like we would expect of humans, not advancement on the model of human advancement or progress, which is debatable anyway, but it's still a tradition of tool use. So chimps, they have traditions. At this point, I want to talk about something called long-term field studies. Long-term field studies, that is, people going out to where apes lived and hanging out with them, studying them much in the same way that cultural anthropologists study people. This was not something that was done for a long time. Up until the 50s, research on the social lives and the cognitive abilities of apes was conducted in laboratories and in zoos mainly, with maybe short-term periods of observations done in wilderness. Well, this changed in large part thanks to the efforts of three women known, I guess, sort of patronizingly as Leakey's Angels, right? They were all students of Louis Leakey, whom we will learn about later. And there were three young women, and they were gaining in fame and reaching the public during a time when the television show Charlie's Angels, about three sort of female spies or special agents, was gaining popularity, and so they sort of got this shtick. No, it's not their shtick. They got this label as Leakey's Angels, and I don't know. It's sort of a cute name. It might be a little patronizing, but it's sort of a good way to remember that these three women, as a unit, uh, not really as a unit, but taken together, uh, affected some pretty major changes in our understanding of the social lives of apes. They started to conduct their studies in the 50s and the 60s, and those studies continued for a while. Actually, let me show you these ladies again. I'm not quite done. You probably all know about Jane Goodall, who recently turned 80, I believe. Yeah, right, 80. Um, and her work with chimpanzees. She doesn't do field research anymore, but her field site, which was opened up in the late 50s, has continued to host researchers ever since then. And so the project that she started way back then has been ongoing continuously to the current day. So we have a lot of information on the chimp populations that she studied. That would be Gombe. You maybe have also heard of Diane Fossey, and you may have heard of Diane Fossey because she was the subject of a popular movie called Gorillas in the Mist, where her character was played by Sigourney Weaver. That movie uh, recorded the circumstances of Diane Fossey's death in 1985. She was murdered by poachers. She was an outspoken opponent of gorilla poachers. As you may know, gorillas are very valuable primates on the black market. We'll talk about that later, why they're so valuable. But she was outspoken against them. When she found poachers' huts or supplies, she would burn them. And so she got in trouble with these bad guys who eventually came into her hut one night and or her house at night and uh, killed her with machetes. You probably have not heard of Baruti Gadicus. Uh, she Jane was British. Diane, I believe, was an American. Baruti was Dutch. Well, is Dutch. And where Goodall studied chimps and Fossey studied gorillas, Baruti Galdicus studied orangutans. And she continues to do her work in the field. She's now affiliated with a research site that also acts as a rescue center for orangutans. So these projects, as I said, are still continuing today, being conducted by other scientists. And the outcome of these first long-term field studies, here's Baruti Gaudicus on the cover of National Geographic back in, I think, 75. This is even before I was born. And here's Jane Goodall today. Their studies helped anthropologists to understand that fitness and reproductive success are only really understandable in the context of a lifetime. And that if you want to judge the reproductive success of an individual, you have to judge them over the course of their entire life. And you have to see how their kids turn out. They also are the researchers who are responsible for demonstrating that apes have traditions that are passed on between generations by learning. They were the first ones to suggest that apes and other primates have culture, or, they were the first ones to suggest it in a way that was taken seriously by the public, I guess. And they also contributed an understanding of primate societies as being flexible and as having a number of different organizational patterns. Previous to these long-term field studies of apes, there had been certain biases inherent in the laboratory and zoo-based studies of primate societies that had resulted in a belief that primate societies were dominated by alpha males pretty uniformly. And of course, that research was used as a justification for sort of the patriarchal roles of males in politics and in even science, etc. But these three women, their long-term field studies revealed that actually, no, apes and other primates have varieties of social arrangements, and they do not necessarily all reflect a patriarchal sort of anthropocentric view of social life. So there are threats to apes. These long-term studies, the last thing that they revealed or confirmed for us was that humans are driving the other ape species into extinction. There are three big reasons for this. Number one reason is habitat loss. This is the loss of the rainforests where gorillas live, the loss of habitat for chimpanzees to farmers, and in the case of orangutans, the loss of habitat due to logging. Orangutans, in fact, uh, well, recent research has shown that if deforestation of their habitat does not stop completely very soon, and we're talking about very soon, not years from now, then orangutans will be extinct in the wild in less than 20 years. That's how fast they are dying out now. This is actually something that you can sort of, I guess I can't say that you can do something about, but you can make conscientious consumer choices that will perhaps have an effect on slowing the deforestation that's driving orangutans to extinction in the wild. One of the major products that are being recovered from orangutan habitats is lauryl sulfate from trees that live there. Lauryl sulfate is what is in your shampoo, your soap, and your toothpaste that makes it foam. It's what gives it those suds. If you could just go without sudsy soap, sudsy shampoo, and sudsy toothpaste, maybe buying your toothpaste from Tom's of Maine or buying your soap from Brahmer's, those crazy bottles with all the sort of pseudo-biblical sayings on them, then maybe you can make a little contribution to slowing the deforestation that's going to drive orangutans extinct. Maybe. The second reason I want to tell you about, the second big threat to apes is the bushmeat trade, and that's what we have going on in these two pictures. Yeah, people eat apes. This is a chimpanzee who has been killed and butchered. I mean, it looks like a human being who has been killed and butchered to be eaten. It's, to my sensibilities, it's pretty messed up. This here is a gorilla family, 3 females, 2 juveniles here that we can see. They were gunned down. I forget the story behind this. I think the poachers were also captured on site with the gorillas. You can see bullet holes. This is not some poor farmer trying to feed his family. That does happen, but not as much as opportunistic hunters who are trying to meet demand for ape flesh in cities. In large African cities, ape flesh is sometimes consumed as a delicacy, as sort of a fancy meal, and sometimes it is consumed for medicinal qualities. And it's very valuable. You can get a lot of money for selling ape flesh on the black markets in large African cities. So this is not some poor guy trying to stay alive. These are opportunists. Maybe they don't have a lot of other opportunities, but there's got to be something else going on. And the third threat to apes that I want to tell you about is disease transmission by humans. This one's pretty straightforward. As humans and apes come into greater contact, humans are passing on respiratory infections and viruses to apes. And we know that this has happened in the past. The current consensus on the origin of the AIDS virus, HIV, is that it was originally SIV, simian immunodeficiency virus, that was in chimpanzees. And then humans hunting and killing and eating chimps, not having sex with chimps, but rather by killing them and eating their flesh, contracted HIV in the blood in their flesh. And that SIV eventually mutated into a form that was more suited for humans and genetically drifted into the form we now call HIV. SARS may have been transmitted to humans initially by monkeys in Asia. At any rate, we know that disease transmission occurs, and that respiratory infections like colds, simple colds, which are no big deal to us, passed on to apes can be very virulent and can kill them. So these are the three things that are driving our closest relatives to extinction. And so these are perhaps the three most pressing problems for people who are concerned with apes. These are two more videos I'm going to put up on the website. That's it for this lecture. That's the primate taxa. That's your situation among the other primates. Next lecture, we'll start talking about the story of human evolution and where we fit in. We'll also talk about some of the ancestors of these other ape taxa that I've mentioned in this current lecture. I'll see you there.